Well, let's continue and see the dataset perspective before ingesting it into Driverless AI. Well, here we have a traditional spreadsheet in the tabular format. So this data came from a classification default problem from Kaggle. We made some modifications here in order to explain the concepts. So first of all, it is clear that this data set is pre-formatted already. So for example, we already have like rows and columns well defined here. The unit of analysis is well defined. We also have the target variable defined in order to create a supervised experiment into Driverless AI. So what's important to mention here? This data set is exactly what we need to create an experiment into Driverless AI. We don't need to do extra preparation like filling gaps or missing values, creating new dummy variables or encoding categorical variables. Most of pre-processing steps or feature engineering steps are done automatically by Driverless AI. But we still can face some common issues when handling with data, issues exactly like this we are seeing here. And if we want to handle with these common issues with our unique approach, so for example, for filling gaps or missing values, in some situations, we might prefer to use some descriptive statistics like average or median, etc. If we want to prepare the data like this, we can do this inside Driverless AI. So let's take a look how the data looks like when we ingest into Driverless AI. Here we are at the Datasets tab from the Driverless AI, and everything we need to start to work with the data is drag and drop the data into the Driverless AI. Driverless AI will compute some descriptive statistics in order to investigate and understand the data. So it's quite important to take a look into the data before jumping into an experiment. So in this details tab here, we have every single column that we ingested with some mean, minimum, maximum, standard deviation, some descriptive statistics that is important to understand: number of missing values, number of unique values, etc., etc. What if we want to perform some analysis in order to change some column data format, in order to exclude some rows, in order to create a new column here? So we can do this, and we can handle with some different data quality issues into Driverless AI. The most common data quality issues that are missing or incomplete data, duplicate or data format errors, outliers, we can easily handle into Driverless AI. Other data issues we might need to investigate before ingesting the data, but everything that we can change into Driverless AI is made with a custom recipe, a custom data recipe. That is a piece of code where we are implementing Python code in order to perform some modifications into the data set. So after we have the data ingested, we can jump into the dataset actions, data prep. Here we also have some other situations that might be useful. For example, splitting the data into the train and test, defining the dataset proportion that we are going to, the train step and the test step. We can perform some joins, left joins, in order to connect this initial data with some sort of extra data that we have also ingested into the Driverless AI. In the live code option, or the apply existing data recipe URL, or upload the data recipe, are the options that we have to implement a piece of data prep code here. Into the live code is where we have the option to create our own code to conduct some analysis. In this case here, I am importing a pandas library. I am converting the X, which is our data set here, into a pandas data frame. And I am also removing some NAs, the missing values that we have in the annual income. Imagine that this is an important column for our analysis, and I don't want to consider individuals where they don't mention or they don't bring the annual income information. So we can use the drop NA function. Here we are in a textually free situation, so we can use anything we want that is implemented into pandas, NumPy, etc., etc. We can transform a specific column to numeric. This column here is a categorical column. We can convert into a numerical one. We can sort the data by multiple columns. We can create a new column that was not present into our data set before. In this case, I am creating a weight column, considering every situation where the loan amount was greater than 20,000. We can drop a specific column. We can slice the data, filtering only the data information where the home ownership is different than other. So there are several functions that you can apply into this part of data recipe. You can also get a preview of this data after applying the function here. So you can see that there is no longer annual income not filled in this situation here, and we can just apply the function. So after we apply the function to modify the data, we have a new data set into our datasets list. So it's not something that we are losing the previous data format, but we have a new data situation here. Well, this is pretty common to most of the cases where we want to reuse something that we prepared before in terms of code, and we can create and save data recipes into driverless AI and reuse or share with different users. So we don't need to recreate the data recipe if we want to apply to a new data set, or to a new data period, etc. So let's continue from some best practice to understand the data preparation. Well, when we are thinking about preparing the data to machine learning, we have to think about the 2 steps that we have in the machine learning project. The step 1, that is the training phase, is where we need a bigger data set, generally thousands or millions of rows that are going to be used in order to train the data. So once the objective here is to create the model, it's huge, important that we consider most information that we have in order to achieve an interesting model performance. So the data set size in this step is bigger than the step 2 that we are going to score the data. The step 2 is where we are just consuming the model. So in this step here is where we need just a few of rows. Even a single row of data set can be used in order to consume a model. And we can also imagine that the frequency that we are going to use the data is different from these 2 steps here. So in the first step, we are going to train a model, and once we have the model created, we can use it like for months or even years. The same model created with the same data set that we generated in the training step can be used for a longer period than we need to consume, because the model, when ready, it is just something that we can use, share, or consume in a daily, monthly basis. But the idea of a model is to have something that will help us to take actions, to make some decisions. So the frequency we consume is greater than the frequency we train. Of course, that there is a situation where it depends on the use case, the data set variability, etc. But generally, these rules apply most of the cases. So let's take a look into our data set example here. Imagine that we used all of these 39,000 rows to train a model, and once we have a model trained with the target variable that we want to predict, that is a binary classification problem, we can think about only a single row as a data set to be used in order to perform the model consumption. So imagine that only with all the information that we use it to train the model, minus the information from the target, but this is a new and fresh data from this single loan request, and we want to predict, we want to generate a new column here that is the prediction of default. So even a single row can be used in the second step. Here we have a representation of how the data set looks like. The step one is all explainable variables plus the target. And the step two, the scoring phase, we must use exactly the same columns, same column names, same column data types, but we don't have the target variable. So in terms of number of columns is n-1. And the output of this step here is exactly generate the prediction column. The prediction for every single row that we are sending a request to the model. The last concept and important thing to mention related to data preparation is the target leakage and how to avoid target leakage. Well, what is target leakage? Target leakage is basically data that you don't know at prediction time. And what target leakage causes? Target leakage causes contamination, and contamination that can leads us to a overfitted model. So if we use a data that is leaking with our target, we must be concerned about overfitting risks. It's important to mention here also that driverless AI also has some target leakage identification functions in order to prevent and in order to avoid automatically the leakage situation. But when we are preparing the data, so let's take a look into the data again. If we are creating the trained data set, we can't use an information that is not going to be present at the time that we want to consume the model. So the training data set looks like this. We have several different informations, loan amount, term, rate, installment, and length, etc., etc. Everything here is something that we will know at the time we want to predict at a new record is received. But imagine that we want to use something like default reason, which is the most clear example that we can use here. So for every single row where we had the default, a bad payment, we are registering the reason why they defaulted. Oh, lack of money because etc., etc., etc. Here is because something else, etc. So this kind of information is a clear data leakage because it's only filled for the ones, but also because when we are creating the step 2 data set, the data that we need to use to predict. Let's go to the example number 2, where we want to send some requests to predict. We don't know the target, but we also don't know the default reason because we don't know if they will default. This is exactly what we want to predict. So this is data leakage, and we need to avoid this kind of situation in our data before training a model. If you have potential leakage in your data set, Driverless AI will point them and send you some notifications about it. But something that I always mention is, if you know something about your data, it's better to apply your knowledge before expecting the machine to understand this knowledge you have. So with this part, we finish the machine learning data prep for success step, and we will continue with the data prep chapter 2, principles for time series data preparation in the next course. Thank you.